Good afternoon, everyone. Welcome to the first ICE Explains lecture series of the Institute of Civil Engineering, ICE Explains, the 2020 Marikina and Cagayan flooding. My name is Amy Bren Villalba. I'm an assistant professor at the UP Institute of Civil Engineering, and I will be your host for today. So as of the moment, we have 357 participants here on Zoom, and we are currently live at Facebook. Thank you everyone for spending some time with us today. We would also like to acknowledge our partner for this event, the Philippine Institute of Civil Engineering. So today's lecture aims to shed light on the recent flooding events in Marikina and Cagayan. It aims to answer the questions: what led to the floods? What are the mitigating measures to prevent them from happening again? What are the basic dam operations? These are just some of the questions that Dr. Tabios will clarify in the lecture. So after his talk, an open forum follows the short lecture. So to start with, may I call on our Institute Director, Dr. Maria Antonia Tanchuling, to give us the opening remarks. Ma'am Tonet?
Magandang hapon po sa inyong lahat. Welcome to the first episode of ICExplains. ICExplains is a platform wherein we, the academics, would like to share our knowledge and results of our studies to the public in a manner that is understandable and comprehensible even to the non-specialists. So at this time, we really need to shape the public opinion and make decisions based on science and evidence. So this afternoon, as a first offering of this public lecture series, we thought of the topic regarding the recent floods that happened in Marikina and Cagayan. So there's a lot of questions and speculations from the public that we want clarified. So hopefully this afternoon we will be able to do that. So I wish you all an enjoyable and educational afternoon. Thank you.
Thank you, Ma'am Tonet, for your opening message. So now, the wait is over. So just a little housekeeping before we get started. So if you have any questions, please type them into the question box after the presentation. So before we proceed with the talk, I would like to introduce our speaker for today. So Dr. Guillermo Q. Tabios III is a professor emeritus at the Institute of Civil Engineering and research fellow of the National Hydraulic Research Center at the University of the Philippines, Diliman. He teaches and conducts research in stochastic and computational hydrology, hydraulics, and water resources engineering. He obtained his PhD in civil engineering from Colorado State University, USA in 1984, and his BS and MS in agricultural engineering, major in land and water resources engineering from the University of the Philippines, Los Baños in 1977 and 1979, respectively. He is an academician of the National Academy of Science and Technology of the Philippines and a member of the American Geophysical Union and International Association of Hydro Environment Engineering and Research. So everyone, let us welcome Dr. Tabios.
Thank you very much, Amy. So, good afternoon to everyone. I had a difficulty getting in because the password was not correct or something. Anyway, let me share my presentation. And I'm gonna put this in full screen mode. So everyone can see this one? Amy?
Yes,
This
sir.
okay?
Yes, sir. We
Okay.
can see your screen.
Okay, so let me just clarify. I think the title Marikina and Cagayan flooding, so I just inverted because I wanted to present first the Cagayan River Basin flooding. That should be only flooding, not floodings. And then later on, I'll talk about the Marikina River Basin. So I haven't done actually study in Cagayan River. I had several, maybe 2 or 3 proposals to do a study, but never happened. But I'm quite familiar with the reservoir operations of Magado, as well as the area above Magat, but not quite the Cagayan River Basin. But Marikina River Basin, I'm quite familiar with it. So let me jump right away to Cagayan River Basin. I had these rainfall maps provided by Professor Mahar Lagmay. So he gave me these maps and told me that these are rainfall maps generated by UP Institute of Environmental Science Management. But anyway, what I'd like to show here is the extent of rainfall over 24-hour period, 8 a.m. to 8 p.m. I mean 12 hours, sorry, 8 p.m. to 8 a.m. You can see almost reaching 100 millimeters over that 12-hour period. So especially at the height of the storm, this is the area where we had the Cagayan River flooding, of course. We have almost 100 or so or more. And then you have a little bit of a lull in the middle, but in any case, I think we'll see later on that Magat Dam in particular has this hydrograph where the peak flow happens sometime 11 in the evening. We'll see that one. But anyway, you must have already plenty of water coming into the basins on the evening of November 12th after this big rain. So as far as the rainfall, these are observed rainfall, again, courtesy from Pag-asa. You'll see that in the Magat watershed area, you have these different rain gauges available, 1, 2, 3, 4, 5, 6, 7, that are available, which you could use as far as maybe if you have a model of the inflows and then do a real-time operations of the reservoir and then look at the flooding conditions downstream, perhaps that will be a lot of help. But in any case, just to give you an idea, during the Typhoon Ulysses, actually, the rain storm was quite long. I think there were satellite pictures where the eye of the storm was already approaching the Philippines, and then you can see the rain band all the way to Alaska. I think I've seen that one. It was a massive long tail storm. Actually, it's like a big dragon, coming into the Philippines. In any case, you can see the rainfall per hour on a per hour basis. You can see maximum only 20, 25 maybe here in Morgan, which is somewhere. By the way, this is from Gamu, somewhere here, Aurora, Halong. For those of you familiar with the Cagayan River, I think Executive Director Tito Aliga, maybe you're familiar with this. Anyway, so you have all the way to the mountain area, and the highest elevation is, rainfall station is located in Imugan. So that's why you see more rain intensity. Much more rain intense in that area. So as opposed to the lower Gamu is, I think, a lower portion. But you can see right away the spatial distribution of rainfall. So that's the reason it's quite important to, if you do some flood modeling, a big area like this, you can see a distinct spatial variability of rainfall. Now, as far as the water level, unfortunately, we have only a few. And this again from Pag-asa. They have two stations in Bunton and then Tomawini. Bunton is a little bit downstream of the Cagayan River, and then Tumawini is a little bit downstream of the Maris Dam, and then the Magat Dam is somewhere here. So, if you want to make sense out of this, supposedly you should have a ground elevation. But unfortunately, we didn't have the ground elevation at this location or these stations. So we can only say that the flood level went up to 12, but I don't know how much what was the flooding depth. But apparently, if you think in terms of the river, uh, 10 meters elevation, water elevation, went up to about 4 or 5. Maybe that has, I mean, we've seen pictures that should have already overflow, already went over bank flows. And the other thing is that I don't have the flood, the rating curve converting your water level to your Q. But let's take a look at studies about the Cagayan River Basin, and we'll see that if you look at the river basin itself, you can see this, right? This like your, what do you call this, a durian, if I were in Mindanao. And then all of a sudden, the trunk of the durian, the one it's at the north end, which is a small area from this big, I think it looks like durian or lanka, danka or nanka maybe. This big thing, and then all of a sudden it narrows. So you can expect that definitely this is just like we'll see later on the Marikina River Basin, same thing. Big, like Mindanao, and then all of a sudden Marikina City is like Zamboanga City, Zamboanga province. So this is really like sort of a recipe for disaster, as far as watershed, which has very flat land here, and then all of a sudden it narrows down. And I think there are issues about this nasipit narrows or masipit narrows, where somewhere here you have really significant river constrictions. So just try to remember the Magat River is here, and then on the western side you have Alimit River, you have Sifu, and then it joins Magat. But then downstream of that you have, Alimit, Ibulo, etc. But downstream of that you have Sifu, Malig. On this side, on the right-hand side of your screen, you have like the Ilagan River and the headwaters of Cagayan River going down, and then somewhere a little bit, I think, north of Santiago, that's where the 4 or 5 river systems join to become, the big Cagayan River, and then it's joined again by these other rivers, Tomawini, Tugigaraw River, Chico River, and all in all, they say about 21 river basin. We'll take a look at that. So when you do, of course, watershed studies, it's always important to know the basin delineation, because sometimes that's always the problem with you don't know what's the kind of where the roads lead to your Quiapo church, for instance. So you don't know how to go there, how the traffic flows, if you don't know the road network. Same thing with the river network. You have pathways here and there, and then, so if you look at the Magat Dam, again, just a perspective here. Magat Dam is somewhere here, but the Magat watershed covers about 5,100 square kilometers. But the Magat Dam in particular, it only covers upstream of that associated to about 4,100, I think, square kilometers. And the rest of the Cagayan River Basin, you have about 27,000 square kilometers. So that will give you an idea that if I were to do Magat dam operations as a flood control dam, I will only be able to capture this much of the area, which is, they always say, in here we always say that, well, that's only 16% of the total river basin, 4,100 something divided by 27,000. So just a perspective. So I think I got this from the internet. Dr. Balderrama, I think he had some collaboration on the Cagayan River, Isabela University, and then some Japan universities. So that's a picture. Now, I got another, there was a study done by UP Los Baños. Principal investigator was Professor Rex Cruz, Dr. Rex Cruz. He's also my colleague in the Academy of National Academy of Science Technology. He has this climate responsive integrated master plan for Cagayan River Basin. I think it finished in 2017. Just to give you an idea that he has even refined the basin delineation in the Cagayan River Basin, and instead of only just about 11 or so, you have 23. Again, just some perspective here. If you look at the somewhere here is I think somewhere here is the Magat Dam. The subbasins associated with that are these subbasins 3, 4, 5, 6, 7, 8, 9, 10, I think. Yeah. So there's a total of about 5,100 square kilometers, just like the one I showed earlier. So here you see a better picture of the network of channels leading to, joining the big Cagayan River. I come from Mindanao, so we have the Rio Grande Mindanao. So maybe, Cagayan River Basin is the biggest river basin in the country, in the Philippines. Maybe we should call this the Rio Grande Cagayan, something like that. Now, if you look at this map, this is the elevation map, and then you can derive the slope map from the elevation map, but look at how steep this area are. Over 1,000, of course, you have the Caraballo Mountains, the Cordillera here, and then of course the Sierra Madre maybe on this side, but in any case, you have the steep slopes around here, and then the flatlands or the big Cagayan Valley here. So later on, we'll see that when we have the steep slopes like this, 50%, 50%, you'll see some channels or river, mountain streams that are straight, brings a lot of sediments, etc., because of the steep slopes. And that's again, as far as depositing sediments in the river and then shallowing the river. That's again a recipe for disaster, flood disaster, if you think about the river basin. Again, these are from Dr. Rex Cruz, and they even have a flood susceptibility map for the Cagayan River Basin. And then in that report, they have some suggestions about the flooding, etc. So you can think about it. This 2017, but I'll show you. I don't know if you can see this one at the bottom. It's not so clear maybe, but they came up with some numbers here. I'll just give you some idea. The 100-year peak flow for Magat River is about 14,000 cubic meters per second. And then you have in the mouth of Cagayan River, 21,000, I'm sorry. River mouth of Cagayan, the mainstream, 21,000. So if you look at it from this point of view, well, you can always say Magat River Basin has a peak flow, only contributes 16% of the total river basin. Perhaps that particular area, historically, because these are from based on historical data. Almost half of the peak flow, it seems like, is associated to the Magat watershed. So that's kind of a little bit of a, how could that be? But anyway, another one here, the Magat River mouth, it says 10,600. So maybe this 10,600 is more, it's a better number. But we'll see later on that this is an issue with different modelers, or different analysts may come up with a different number. But anyway, what we were saying here is that they suggested about what to do with the flood control, etc., etc. In fact, they need about 8 billion to do this one. Now, DREAM, actually, the DREAM project with Professor Mahal Lagmay, my friend, who was heading this, and with Eric, Dr. Eric Paringit, the DREAM project in particular, did also flood inundation studies here. But anyway, these are the results they've got. So again, this is in terms of the flood hazard map, in terms of, I think, the water elevations, and then this is the flood depths. Now, sometimes maybe this is more meaningful if it's a flood depth compared to flood elevation, as I was saying, unless you know the ground elevations or the bottom elevations of the river. But their estimate comes up only the entire Cagayan River basin, 15,000, the 100-year flood, 15,000 cubic meters per second. The study by Professor Rex Cruz, about 21,000. So that's here and there sometimes. In any case, what I'm trying to just show here is that you can come up with these results about 15,000, if it's 125, and so on. Because again, as I was saying, I'm just showing these results because I haven't done a calculation myself. If I have a model of Magat River, I mean, not Magat, that even the entire Cagayan River, I could have just done calculations just like what I was doing in the Marikina. But anyway, just kind of remember 21,000, 15,000, and so on. And then the Magat, maybe you're talking about 10,000. And again, I'm going back to Professor Rex Cruz. As far as the slopes, which are very steep slope, another suggestion they have is slope stabilization, and then of course you have sediment containment systems. Now, Dr. Rex Cruz is a forest hydrology. He does a lot of watershed conservation, so I think he sees right away that this is a big issue as far as the soil erosion, which is quite important because I think the Magat River, I mean the Cagayan River in general, or all the tributaries, has accumulated a lot of sediments. And I'm going to show you in Marikina, it's same story. A lot of sediments, and a lot of times when we do flood control, we seldom really look at the importance of soil erosion and then sediment control in your watersheds, which in the long run will really change your river landscape and your flooding scenarios, or your flooding situation. Okay, so this is from Japanese study, and I'll show you later on I forgot to put the billings or the acknowledgement here, but you can see here that this was a survey in 2000. What's important to understand here is that this is coming from upstream, and then you're going downstream all the way to but what I'd like to show here is that you have this Magapit bridge to Alcala. No, maybe this one, the bankful carrying capacity of the low water channel. So at the river mouth to Magapit Bridge, it carries about 9,000 to 25,000 cubic meters per second. Then when you go downstream to Alcala, 4,000 to 20, and all of a sudden, you have only 2,000. In fact, to exaggerate, sometimes they say that the outlet of Cagayan River to Babuyan Sea is only 2,000. Can you imagine that? Then the water will just stay there for a long period of time before it goes out. Just like your Laguna Lake, the outlet is Napindan. It takes so much time to remove excess water from Laguna Lake. So so I think this is quite an interesting result where you really see the bottleneck. And I'll show you later on some flood mitigation plans that were done. Somehow I'm kind of going back in time here. So in 2006 to 2030 master plan of the Cagayan Valley, this with the RDC, Regional Development Council, they did some what you call this problem tree, and then they have like this. This is a nice picture, by the way, just schematically showing the entire Cagayan River, and then you have the inflows of tributaries getting in, and then you have the cities of Santiago, Magat River, Ilagan River, Tugigaraw City, and then you have Tugigaraw River, Chico River comes in here, Malig and Sifu River comes in here. You can more or less see. But if you look at their plan, their Cagayan Valley Flood Master Plan, it's about 132 billion pesos. They have short-term, urgent, and then long-term plans, and it's so many things: river widening, flood walls, and etc. etc. You can Google actually there. Was that all the plans? But some of them were really, I think, were taken from an older master plan, which was conducted by this one. So this is quite interesting. In 2002, and then they have some more reports in 2004, the JICA, Japan International Cooperation Agency, funding this study for DPWH, did a lot of, all kinds of suggestions as far as the flood control plan in the Cagayan River Basin. And the cost of this is similar to the RDC 130 billion and so, but a little bit low. I mean, lower. The price was lower during the time until it was updated in 2016 or something by 2006 and so on. But I think these were, I think if you see in the news lately, they've been talking about DPWH's plans to build 6 dams along Cagayan River. And those 6 dams, I don't know, it says here, please move this window away. But anyway, there are the 6 dams, which are this: the Matuno Dam, Cagayan Dam, Alimit Dam, you have Ilagan Dam, Sifu Dam, Malig Dam. And then the 3 of them, they said it's a multi-purpose dam: Malig, Sifu, and then the old Magat Dam, which has this flood control allocation storage. But the rest, it's a pure flood control dam. That means when it's a pure flood control dam, no other purpose. Before a typhoon comes, they will empty the whole thing and then try to accommodate the entire thing. But depends now if how big are those dams. I mean, how big is the capacity or storage in volume, storage volume of those dams? Because I'm going to show you, we also have a plan like that in Marikina River Basin, but then you may be limited by the number of, by the flows that will come in. But anyway, this includes diking here and there, and then this is what you call the narrows, masipit narrows here that needs to be widened, dredged, and etc. etc. So this is quite a very comprehensive plan, almost 20 years ago. But of course, we haven't maybe. So here again, you see the historical floods, 1973, 1980, 1995. Now, let's go to Magat Dam. Actually, Nia gave me a time series of this in Excel, but I forgot to, I didn't have time to plot it, but fortunately, Professor Mahar gave me this. So if you look at this plot, essentially, at the height of the storm, which is sometime uh, 12 a.m. Oh, and here's the start, 12 a.m. November 10, but after almost 72 hours, somewhere like, 3 days after. So 10, 11, 12. And I think that was in the evening of, or before the midnight of November 12. They have come to a point that the Magat Dam was reaching what they call the elevation that they don't want the water to go beyond that, which is about 193 meters elevation. So at that point, they operated the dam such that the inflow is just almost equal to the outflow. So as if there was no dam. So in other words, it did not try to contain the dam except this time, the flood waters. You notice this one, the inflow is high, but the outflow, oh sorry, yeah, this one, the blue one is the outflow. So it's a little bit low, and then they started to catch up because they don't want. But of course, maybe around this time, maybe that's when people thought, oh, the outflow is a little bit bigger than the inflow. But anyway, at that point, whatever is the condition downstream, whatever outflow you release or you add coming from the reservoir, then you will be blamed for, oh, you have sort of that's the straw that broke the camel's back, something like that. So there you go. Instead of being flooded maybe up to your neck, all of a sudden you cannot breathe anymore because the flood is above your eyebrows, something like that. Anyway, so let's take a look at this carefully later on. Now, of course, Magat Dam, according to NIA, is not designed for flood control. And I'm going to show you, I'm going to show you what exactly, but in any case, in 2007, October 31, there was a memo which was agreed upon by the owners of the dam and then several signatories, the SN Aboitiz, the Pag-asa, the Napocor, and so on. And then they said here, I don't know if you can read it, it is emphasized that there is no provision for storage of flood water in the Magat Dam. In other words, as far as the operation of the dam, when the water reaches 193 meters elevation, they will just release the water. Now, why 193? Perhaps they have long-term objective that they want to retain water up to 193, but beyond that, they will no longer use up the flood control allocation storage because they have no flood control function anyway. So that's what happened. And that's a memo that's, in other words, if you follow this memo, which is what they have done in the last several years, they have essentially followed the protocol, which is given by this, where the inflow is equal to outflow because actually at this point, that's why, as I was saying, I was given the time series of the elevation of the dam. It was really reaching 193 or 192 and so on. But that's the time that it hit this one, so they never wanted to go above 193. So that was okay. Someone is raising hand, but maybe we can entertain questions later on, right? This so many raising hand. Anyway, so let me go to the design of the dam. It's like this. In 1982, they started the plan this in 1978, but 82, 86, I think when it was formally commissioned, the flood control, the the Magat Dam has these specs. The crest elevation of the dam is 200 meters. The bottom elevation where you can draw water is 160, so it's the minimum supply level, you call it MSL. And then the full supply level is 193. But they have, before that, they even have like, during the flood season, 190. But anyway, now between 193 to 197, you can operate the dam up to 197. And this is more or less what you call the flood allocation storage. But after that memo, they no longer have a flood control storage. So they don't want to go above this one, because if you go above that one, then you're saying to yourself that, well, I'll try to contain the flood. I will do a little bit of a flood control function or flood control, operation. That's the idea. Now, remember that this is a little bit of a, sometimes a misleading. They say that the spilling level of the Magat is 193. Actually, the spillway crest elevation is 174. So even at 174 elevation or 175, you can already spill water from the dam, or you can already evacuate or release water from the spillway, through the spillway, right? So supposed to be, the only reservoir I know in the Philippines that has a real spilling level is the La Mesa Dam. It has like 80 something, 80 meters elevation, DPW's datum. When it reaches that, it will just spill. No control gates and so on. This one, it has a control gate, so it's a little bit, even the Magat, even Angat and San Roque, they also, Angat has a spilling level of 210. Actually, Angat, I think, as the spillway crest is about 202. So you can already start removing water. What I'm trying to say is this. If there is an issue with the dam such that you don't want to operate it beyond 193, but if you wanted to insist that Magat will try to contain some flood, then maybe before a storm comes or typhoon comes, you lower the elevation to say 175 or 185 or 183. But if you do that, of course, you relegate some flood control function to Magat Dam, but maybe at the expense of later on the long-term objective, which is to provide irrigation water. What I understand with in the Magat Dam, even though it has already some sedimentation, actually the numbers here, these already like the dead storage is now about only 90 MCM instead of about 300 because of sedimentation. Instead of the total storage is 1,260 MCM, is only about 800 something and so on. But anyway, 300 MCM or so sedimentation. Anyway, my point is that if I were to assign a flood control function, if Magat brings down the water to 185, what I know is that if the storm did not come, so you gambled, in other words, that you will be able to fill it up anyway when the storm comes. If it did not come, from 193 to only 185, maybe you lose more or less, what I know is 15,000 hectares out of the 85,000 hectares that you will be able to irrigate in the next cropping season or in January or so. Because I think the cropping season there is January to May and then June to October, something like that. So, 15,000 hectares is quite a lot. That's almost a little bit over half of the irrigated field in the Angat Maasim, for instance. So that's, I think, a compromise you have to take. So you have a long-term objective is irrigation, and then also the hydropower, and then you have the short-term, which is the flood control. But how do you do the trade-off? How do you, do the balancing act of you want to save water for the irrigation, but yet you wanted to spill the water now because you have flood control. But if you do a flood control function, you have to realize also, what will be my impact? Will I really impact when the Cagayan River is already running 25,000 cubic meters per second for all the watersheds, and then I'm going to add additional 3,000? Will it matter? Something like that. Anyway, that's the sort of the contentious issue when it comes to flood operations. Just to show you the Magat Dam accumulation. So now you have effectively about 800, as I mentioned, from 1,200 MCM. So that's 1.2 giga cubic meters, originally. Now, this is the report I'm talking about, because I was trying to find an explanation why they lower down I mean, they don't want to have a flood control function above now 193 anymore. Because I guess you can hear in the newspaper, it might compromise the dam. But this was a 2018 study, but published in February 2019. This, I don't know who funded this, maybe Ministry of Economy, Trade and Industry of Japan, but done by Nippon Koei. So this is the Magat Dam. So this is facing towards northeast and so on. So I thought that there was an issue with the spillway. Maybe that's the reason why you don't want to operate above 193. But according to this, they did a site reconnaissance study, and then major finding, there seems to be no significant issue with the dam structure, with the spillway, with the the only thing that's quite a big thing is the sediment yield. You have a lot of sediment yield, especially after the 1990 Baguio earthquake. So that's a problem. But it says so far no serious problem. But the dead storage, as I mentioned, you still have about 90 MCM. In other words, when you design a dam, and this is an old school design of a dam where there is a finite life, you put a dead storage to accumulate sediment, and after that, it will keep on accumulating. No way to flush it out. Anyway, so even from the point of view social, environmental, they mentioned about this and that, but no issue. So I just want to show you what's the difference when you assign a flood control function in a reservoir before I finish this Magat Dam issue. So in 2009, we have this Peping, October 2, and then typhoon came, it went out, came back a little bit the north side of the Agno River Basin, went down October 9, and then that's when you have this big bombshell from Agno River. But if you look at Agno River, I mean, no, not Agno River, but San Roque Dam, similar to what I was showing earlier, when it was designed, or even now, the dead storage is about 300 MCM, 520 is the conservation storage, up to 280, from 225 to 280. And then between 280 to 290, that's the flood control storage or flood allocation storage. So if you look at the flood operation, this is very much similar to Angat or even Magat to some extent. When the typhoon is so much away from the Philippine area of responsibility, PAR, is still far away. The PAR is still not in, then maybe you don't do anything. But once it gets into the PAR, depending on this and that, maybe you start doing some releases. But if it's below 280, you don't spill anything. Anyway, during Typhoon Pepeng, this is what happened when you try to do a flood control operation. So this is the actual time series of what happened. So the black line here, or curve, is the elevation of San Roque from 277 here all the way to 289 around October 10. Yeah, 2009. They reached 289.5. 0.5 meter away from the critical sort of point in the dam, where you'll be hitting already the ceiling of the dam. Once you do that, you could maybe just hit the bolts here and there. You can start skimming and stripping the headworks, then you're in trouble. So you don't want to do that. But that's what happened to them. The typhoon came in October 2 or 3. This was the rainfall. They kind of, by the way, the inflow is the blue one, and then maybe just worry about the spill plus power release, which is the yellow one. So they were just releasing a straight line here because that's the power generation. But when the typhoon came back, I have a full sort of narrative on this because I was the chair of the investigation committee in the Senate. They started spilling because they were noticing even if there was no rainfall, the typhoon was coming back, but it was coming back from the top, from Cagayan Valley. But then when it hit October 9, 8, 9, the rainfall just started raining a lot, 30 mm and so on. So they started releasing water. And then here they were hitting almost 289. They just had to release what is more or less equal to the inflow. So they never really released more than the inflow, of course, although they can do that in a spillway. I think in the San Roque, they can even spill all the way to 13,000 cubic meters per second. By the way, Angat has a spillway that you can spill even up to 34,000 cubic meters. But anyway, here, you can spill 13,000, but here they only spilled 6,000 plus, 5,200, I think, if I remember correctly. Plus the generation, they were just, no holds bar power generation here. So as if there was no dam, what comes in, they just let it out to protect, of course, the dam. But this was already a very critical, tense kind of operation because you're hitting, the top of the dam. So that's the problem. So in fact, after that, I was toying with some way to do optimization. Congressman Mark Huangco then during the time was interested. What if you do preemptive release? What could have happened? And so on and so on. So from the original, this one, you can do preemptive releases here, small here and there. And look what happened. It only reached up to 287, maybe here 280. But this one, the point is that the actual outflow is only 3,000. We tried to time it in such a way that the total release is only 3,000, not the 5,000, which is the devastating amounts, discharges that will flood San Miguel, Tayog, that area, Singan area, and so on, downstream of San Miguel. So that's basically what I'd like to say about I have to hurry up because otherwise no more time to do questions and Q&A. But I have some suggestions here and there. Again, I'm a member of the panel of this, the Magat Dam, so this may be suggestions that I'll put. But the bottom line here is that these were the same suggestions I did in the San Roque, but of course, I don't know what they did. But in fact, this one I'd like to impose, I'd like to just point out that flood operations, especially for dams, could be three-tiered. You have a long-term flood control rule, you have a short-term, and then a real-time flood operation rule. So here you need a dynamic anticipatory control feedback flood operation model, et cetera, et cetera. Anyway, and then of course, flood inundation model downstream, and so on. So now I switch to Marikina, kind of put this right away here, but because I just, earlier I just put in this slide, but I should have removed this title. Last January 20, I made a presentation. But what I'd like to just show here is this one. In Marikina, in Metro Manila in general, you have these flood-prone areas. But the Marikina Basin in particular floods Marikina City, this area in Cainta, and then the what you call the city of Manila. But of course, you have all other flood prone area in Kamanava coming from Tolyahan River. It's coming from your La Mesa Dam, etc. And then South Korea in Parañaque, flooded area. I think Magallanes and so on here. And then Las Piñas, Zapote River and so on. So what I'd like to show you is the flooding in Marikina, which is, so forget about this title there. Forgot to remove that one. So again, during this time, if you look at I got data from EFCOS, Effective Flood Control Operation. This is run by MMDA. These are the rainfall at the different rainfall stations operated by EFCOS of MMDA in the Marikina watershed. So I think if you look at Mount Campana, somewhere here, Mount Oro, and then Langka, etc. But what I wanted you to note here is that if we compare to Ondoy rainfall, but the resulting flood may be similar to Ondoy, the Ulysses flood, you have Ondoy, which has lasted for about maybe 8 to 4 in the afternoon, about 8 hours maybe. But in the case of Ulysses, and then, by the way, the Ondoy, the peak rainfall, even here, Science Garden, almost 90 mm. Total rainfall over 24 hours was like 450. I'll show you that later on. But in the case of Ulysses, you have only 35, 40 at Mount Oro, that's already high. Now Mount Oro is here, the highest point there. Anyway, nothing above 60 compared to Ondoy. But the difference is that the rain lasted for almost 15 to 36, almost 20 hours. So that really, created a lot of this, brought a lot of rain and volume of water that went through your Marikina River Basin. Just to give you an idea, what's the associated return period. But this is just based on the peak flow. But we have to remember that while peak flow is an important parameter for peak rainfall, we have to look at the duration, which is the big difference here. While the Ondoy rainfall over 24 hours was associated to 100-year return period storm, the Ulysses was only 50-year. But this is for 14 hours, 8 hours. I thought it was 24. 15 hours, sorry. Almost 20 hours, I thought. Anyway, that's the difference between the two. So if you look at the resulting water level elevations at the, again, EFCOS recorded water stages, you have maybe interesting to see would be the Santo Niño. So that's the gauging station at Santo Niño Bridge in Marikina, Sumulong Highway. So just across that baseball field or whatever that is. So the Ondoy reached almost 22 here, but this one reached almost 22 also. I think here was 22.3, but here 21 point. So there were some news items that, the Ondoy was lower than the Ulysses. Actually, if you look at this data, and in fact, the simulations which I've done, the computation of that, it's a little bit lower, but yet, here, if you look at the peak flow, it happened, unfortunately, they said the rain gauge here somehow was not working properly. But if you look at the, let's pick up the Santo Niño is here. We should look at this one. What I wanted to show is that this only lasted, the Santo Niño unit, lasted for about 1.5 hours, the peak, as opposed to this one, which lasted for about 6 hours. The peak, you know what I'm talking about. So you see that the peak the peak water elevation lasted for 6 hours as opposed to only 2 hours. So that's something that, it's quite important. And you've seen it in the rainfall that is long, it's a prolonged rainfall. When you talk about flooding, it's not only you get flooded in 1 second, but rather you get flooded. Maybe you don't worry about getting flooded for 1 second, even if it's above your head. Because after 1 second, you can really breathe again. But if you get flooded above your head for 30 minutes, you're dead, right? I mean, you could no longer breathe. So that's how it's important, not only the peak, but also the duration of flooding. Anyway, maybe I shouldn't show this, but I just want to show you the magnitude of things here, like, because I don't have the Laguna Lake levels, although I have Angono here, Angono Rizal, but it's a very, very low. I don't know what happened out there, but just to give you an idea that during Ondoy, you have a quick went down there, but in the case of the Habagat, it took time, which is similar to your your Ulysses maybe, but not quite, but more or less just to give you an idea. So let me get into some of these mitigating measures because it's kind of getting late. So the flood control scheme of the Pasig Marikina River Basin, which is Marikina River originally, it goes straight to your lower Marikina and then into the Pasig River to Manila Bay until 1985 or something, 1986. They built the Mangahan floodway. So before Mangahan floodway, Laguna Lake didn't have any inflow from Marikina River Basin, only inflow maybe around the area in Napindan or Taguig. Somewhere here, it goes, you see Taguig River here, it flows to Laguna Lake. And of course, you have the other 50 or so rivers, small rivers, or 21 large river basins that inflows into the lake. But anyway, the Mangan floodway brings almost about 20% of the flow on the average to Laguna Lake. But maybe in a few hours, if it's a storm, maybe more than sometimes. The other watersheds surrounding the lake, like Panhan, Pakil, San Juan, all those rivers around Laguna Lake also contribute. But anyway, in 1986, we have this very, what you call smart idea being in Metro Manila. Oh, let's move the water to Laguna Lake for temporary storage. And then since Napindan is not going to naturally can only evacuate so much, let's also build the Paranaque spillway. But this sort of infrastructure together, one of them was not built. So Paranaque was not built. So the Laguna Lake towns had to, be patient. But when the water comes into Laguna Lake, it takes so much time to get out. So that's the problem. So what are the mitigating measures? So again, they have been suffering, maybe the Laguna Lake, Lakeshore towns people or town folks. But anyway, they have been tolerating this flooding for several years now. So one of the schemes, it is in the 2010 or 2013 Metro Manila Flood Master Plan. They will revive the Paranaque Spillway. And the latest study in this Paranaque Spillway was in May 2018, 2 years ago. So the scheme now, since it will be expensive to put an open channel on top of, this whatever this area here, which is your PF homes or whatever, I don't know exactly where it is, but it will be so expensive to buy the real estate here. So the proposal is to build a tunnel. But the intake structure is at 12.5 11, actually 12.0. So meter elevation, that will really flood your Lupang Arenda actually, or even that whatever the subdivision in Taguig. I forgot the name of the subdivision, but anyway, if you have this tunnel which drops 30 meters below the ground, and then you have this tunnel here, 12 meters in diameter. Remember, 12 meters in diameter, and then you bring water here, but the difference between the 12, that's the inflow here, supposedly, and then this one is about 2 meters. Because if this 12, actually it's only 1.5 meters. But anyway, if the water here is above 13 or 14, you can have 2 meters head. But once there is no more, the water elevation lakes are at 12, you'll be moving, the head will be 1.5. You have a loss as you move here, so you need a pump. There's a drainage pump. So you have to pump water into Manila Bay. So this is not like your high head, low here, then the water will just flow. If there's no more difference in head, then you'll have a lot of water staying here. So you have to pump it up. So pumping will be an issue. But anyway, in the study by this JICA, the decline in the water level, if they were to simulate Typhoon Ondoy, 0.55 meter from 13.84 to 13.28. If they simulate Habagat, less than 0.3 is the decline. But then they say that anyway, we will maybe build a diking system here, and so on. So these areas, Santa Cruz, Pila, Los Baños will not get flooded. Anyway, there's a cost of about 140 to 150 billion pesos. So, that's some idea, but maybe not a very good idea. That's the 150 billion is part of the 198 billion in that Metro Manila master plan. Of course, this is just a plan. They haven't implemented, but again, you can say this and that. The other option they were, or not really an option, but maybe additional flood mitigation component is you build a Marikina Dam, pure flood control dam. So before a storm comes or a new storm comes, you empty it. It has a capacity of 90 MCM. So that's basically similar to flood allocation storage in San Roque or in Magat or even the original, in the Angat reservoir. But, if you have like the Habagat case, you have sustained flow of maybe 3,000 CMS. The 90 MCM can get filled up in 8 hours. What about if there's another storm? So Ulysses, for example, was even 15 hours, right, or 14 hours. So then you'll be in trouble. I think the Ulysses has a sustained flow of about, in that area in Marikina, about 5,000 when it was hitting 21 for about 6 hours, right, if you remember that. So right away, you can say, well, it's good. It's a very short duration storm. No Habagat, no Ulysses kind of storm. Only Undoy, you can contain it, but once it's filled up, then you no longer have a flood control dam, so to speak. Now, the other thing, the Parañaque spillway, not quite the Parañaque spillway, is that maybe you can dredge Napindan River. But the idea of Napindan River is this, just to give you an idea. If the elevation of the lake is about 12.5, you can only move as much as 200 CMS. If it's about, I think 11.5, if 14, you can move up to 450 CMS, 470 in Napindan Channel. But after 60 days, the level is already 12.3, you can only move 200. Now, I'm giving you these numbers because the Parañaque spillway is designed that it can only move 250 CMS. So it's basically more or less this much. And then it says that the inflow, the intake tunnel, the intake level to the tunnel is at 12. So it will accommodate anything between 12 and above. But the design is only 250. So why not maybe look at dredging the Napindan River? Now the elevation of the Pasig River is this. This from the Napindan, Lower Marikina Junction and Pasig River. You have this elevation, but the Napindan River is somehow silted. So if you dredge it maybe 4 meters, it will look something like that. This is what you can gain. But of course, not so much gain maybe, but still, if you dredge it, you can move. Is the case of this and that. But in any case, Napindan flows, this one, you'll have 184% increase from if you are at 12.5 Laguna Lake and then you keep on going down, almost 150, 130, 40%. And the dredging here may cost you something like 2 billion, maybe 2 billion, because that's only about 4 meters and then maybe by 100 by, I don't know, 7 kilometers. So I would figure it will be about something like our estimate before about 2 million cubic meters times 1,000, so the 2 billion times 1,000 pesos per cubic meter. So that's 2 billion. So, but that's an option, but you have to keep on dredging. Of course, when I was talking one time with Secretary Mario Montejo, he was telling me, why don't we also pump on top of that? You can increase more if you pump, You put some pumping device in Napindan, but it's not going to be pumping like what you think. You pump it that way. What you do is you park a sort of a jet engine where it picks up water and then throws it on the other side, something like that. Anyway, that's an idea, but anyway, the sort of my ultimate suggestion is to put a tunnel. And I think I've shown that the alignment looks like that here and there, but that's not exactly the alignment that goes to Kaliwa, although that option is an option. If you have Laiban Dam, maybe dump some in Alivian Dam, but maybe it will flood Agos River. But the bottom line is this. The Iloilo Flood Control Project diverted the Jaro River. Instead of going to Iloilo City, they have this Jaro floodway. I don't know what's the gain, but definitely is gain. But the other example that we'd like to take a look is the Kuala Lumpur. Kuala Lumpur has this river Klang, gets into the city of Kuala Lumpur. I think somewhere here is your Petronas Tower, which got flooded in 2005, 2008. But anyway, they built, especially the palace, this palace, what a Majid Hamik or something like that. So they diverted the water from here all the way to the sea. But it's a combination of a channel and then reservoir and then a tunnel, which is stormwater management as well as road tunnel. That's why they call it SMART. Very nice name. And then they move water here. But look at these numbers. The tunnel is about 13.2 meters diameter. It's a road tunnel. It's got two deck roadway. The bottom part is a storm water, but if needed, the entire thing becomes a flood channel or flood tunnel. But look at how much they are really just moving. 280 cubic meters per second. We're talking in the case of Marikina, 3,000 cubic meters per second of flow, QMEX, 4,000. So you gotta just, this is already a big investment, 25 billion, but it's only 13 meters, 9.7 kilometers. Anyway, in the case of the Marikina, before I show you the scheme, this is a simulation that I did. If you divert 1,700 QMEX, CMS, the hydrograph will look something like this. Instead of the Ondoy this way, it becomes the red one after you divert that much. So the amount that you divert, the hydrograph that you divert will be something like this. But again, that's the same question that's been asked in the Cagayan River. You tell us 7,000 CMS was, instead of saying only 6,700 came in. What's the meaning of that? Unless you translate it into water level. So this is the effect. If you have Typhoon Ondoy, that's the red one, this plot here is similar to that, except that the bank elevation, this is the looking downstream. If you're in SM Mall looking down to Libis, this is what you see on the left over bank, the bank elevation of the river. If you're looking on your right side, looking downstream, you'll see this is the bank elevation. So this is a Provident Village high wall, flood wall, but the rest, I think river bank here, river bank, what's that? Inuman and so on. That's the elevation. But SM is like that. So if you have Ondoy, several portions got flooded due to river flooding. The river flow went out of the river banks. But if you have this Marikina tunnel, the red one here, I should have inverted the plot. But anyway, this is the effect. You will no longer just flood this area in SM Mall, but especially Provident Village because of that difference of 1,700. So that's basically what happened. So these are some of the alignments. One is really going all the way, but maybe it will cost you. So here it's about only 60 billion. So this was even when in 2010, after Ondoy was doing this and that, and then 2011, I got involved in some assessment of flood mitigation studies in Asia. We look at Marikina, Tubon in Da Nang, Vietnam, the Klang River in Malaysia, it's Kuala Lumpur, and then the Ciliwung River in Bogor, Indonesia, and so on. So I went to that smart tunnel. So I got this idea. So in 2013, in fact, I asked two of my undergrad students in their thesis to do this calculation and so on. So this is the result that they got. So Ramin Lim and Lian Tapel, maybe they're listening. I just want to acknowledge them. So that was even 2013 idea. So these are the cost of tunnel anywhere from 50 to 60 billion. So I think this is the sort of one of the effective, flood mitigation scheme that we can do. In this case, it's just on the other side. Instead of the smart tunnel, it's the same alignment, so to speak, from that point all the way down, like the Jaro River. But in our case, we don't have opportunity to move it on the other side of China Sea, but rather move it on the Pacific Ocean. So finally, just my last remarks here. When I look at flood risk management, it's really a complex problem. It's a dynamic, uncertain, etc., which is a combination of several things: physical, social, human system. In the Philippines in particular, we have this meteorological monsoons, typhoons, even your intertropical convergence zone. And then hydrological, we have an archipelagic setting. The Marikina River, 600, 700 meters elevation in a matter of 20, 30 kilometers, very steep slope. It gets to your flatlands, the Pasig, Pasay, and so on area. I mean, Pasig area, and then San Juan, all the way to Old Manila, which requires what we call this flood holistic management, integrated land, water, coastal hazard management. And finally, after all is said and done, there is this interesting paper, Professor Greg Bankoff. 2004, he was a big professor here in UP Diliman from University of Hull, HULL. In the eye of the storm, the social construction of the forces of nature and the climatic and seismic construction of God in the Philippines, where he observed that Filipinos share this distinctive cultural heritage, which is what he calls actually the culture of disaster, that somehow shaped by the threat of hazard since they are constantly being reminded that theirs is a country exposed to all types of calamities that they have come to accept, that the torrential downpours, typhoons, earthquakes are realities of life, and that theirs is a life particularly prone to calamity, one where they have hardly had time to bury their dead and pick up the pieces before another destruction starts again. And I think the last point here is that we have learned to live so that our schema of things, the way we do things, we already live in what we call this culture of disaster. So I think that's that we always pride ourselves that we're so resilient. But I saw one cartoon one day that this dog sitting on top of this rooftop, it's all flooded all over the place, and he says, the dog says, "I'm already tired of being resilient." So that ends my talk. So it's about 5:25.
Thank you very much,
Thank you very much
Sir
for
Tabios.
listening.
Thank you, sir, for that very enlightening, educational, and interesting presentation. So now we move on to the open forum session. So for this session, we will be joined by Dr. Roberto Soriano, Associate Professor of the Institute of Civil Engineering and Director of the National Hydraulic Research Center. So Dr. Soriano will moderate the open forum session. So Dr. Soriano, you may now have the floor.
Okay. Thank you, Amy. Good evening, everyone. So, Glenn, how do you want to do this? There are
Okay, I'm
already
okay.
there are a lot of questions. You want us to start with the those who posted their questions on. Is this from FB or
Oh, okay, I
yes?
just opened
So
the.
it's before beauty. You can see them if you want to go through them maybe one by one. Uh, so there's first one here on the list is from Michael Montefalcon. Said that during the monsoon rain in Cagayan, average rainfall is about
39
39
inches, so
inches,
40 times 2.5.
2.5. Huh?
So
Yeah, and
about,
then
or
about that,
25 actually.
yes, and
25,
then
so that's about,
uh,
what's that? About 200 mm. Yeah.
mm. and then 120 inches in the southern part of Magadan. Okay, he's mentioning some other rain gauge probably upstream. Um, do you think we need to improve the natural typhoon barrier like the Sierra Madre mountain range for massive reforestation?
Yeah, I think part of the flood risk management, as I mentioned, is really a compendium or the uh, combination of so many things. Like, for example, in particular, like Cagayan River Basin, you have the steep slopes from the mountains, and then reforestation will definitely help a lot as far as containing not the water, but even the soil that will eventually get into the rivers and, you know, reduce the capacity of the rivers. And I think that's where Professor Rex Cruz is coming from, being to really do
Mm,
properly water conservation. As far as the massive amounts of rain, whether you can sort of really create a sponge effect of your forest,
mm,
maybe to some extent, but
yeah,
the big massive amounts of rain will go down definitely.
yeah. Okay, thank you for that. So there's a secondary question here. Is that I'm talking about the mining,
Again,
black
river,
sand
yeah,
mining?
traverses,
Yes, the
yes.
same. Do you think the black sand mining contributed to flood?
So yeah, the black sand mining, I thought it was just downstream. Now, whether it's near the coast to some extent, yes, but you know, you're really talking about how to remove the waters from the valley. I
Mm,
don't know exactly where the black sand mining done, but
yeah.
you know, I don't think it be the bulk of the sediment that's coming in because of the mining.
Mm. Now the other, I think this is the same person, Michael, but talking about if you're looking at sustainable integrated river management. So you're looking at several provinces that is actually traversed by the Cagayan River Basin. How could that actually be implemented, and how could that contribute to the economic development of the area? It's a little
You
bit.
mean these numbers like 59,
Buksan nga yung ilaw, ano?
15 million cubic meters and so on. It's like, well, you can maybe inject to the ground, but I don't know to what extent because that's already a low-lying area, you know.
Oh, okay. You're answering the next question. Okay.
Yes.
Yeah.
Oh, I see.
All right. That's okay. That's okay. Okay. So and then from Jenny, I think you already answered this, right? The maximum water level is 976 during Typhus Ulysses for Magat Dam. Is that was reached already during the typhoon? Yes, right?
Yeah, but I don't know where is that
Was it
976
is it
meters elevation
976? Sorry, but you're talking the maximum. I don't know why 976. I don't know
because the
where
maximum is
this
193
number came
anyway.
from.
But anyway,
Yeah,
maybe
the
it's
maximum is 93, and that
197.6.
is already reached.
Yeah, yeah.
Okay. Okay, so from Melvin, is it possible to construct, of course, catch basin, artificial reservoir, catch basin upstream of the dams to impound, okay, the water instead of
Yeah,
allowing it to directly flow?
that was the JICA study I showed that you have upstream of the
Mm-mm,
Magat Dam, you have Alimit Dam, you have the Matuno Dam,
mm-mm,
you have three of them actually there. So that's an option. Of course, you'll have a cascade of dams, but again, you construct them. By the way, this is a little bit of an aside, right? When I
mm-mm,
look at they have a study in the Magat Dam. In fact, before they built the Magat Dam, in the feasibility study, I was looking at it. The Magat Dam being multi-purpose, the cost associated to the dam with the construction of the dam at this elevation and so on, almost, I don't remember exactly the numbers, but $100 million was associated to the construction cost being a flood control dam, the extra dam with the spillway and so on. And
mm-hmm.
then only about $25 million. Maybe my numbers are not quite right, but anyway, a little bit less than one fifth is associated to the irrigation function of the dam. But so that's the cost. So it's like 1:4. But when it comes to benefits, the irrigation has a benefit of something like 110 or 120. And then the flood benefit is only like 10 because they look at the expected value of the benefit and
Yeah.
expected value of the cost. Of course, the expected value of the cost is
Mm-mm.
almost 100%, right? Because you spend that.
Yeah.
But the expected value benefit to flood control and then the irrigation has a higher probability, the expected value. You can assign a higher probability. But the benefits cost ratio is like about 15, 1.5 or 1.6, not because of the flood control, but rather because of the irrigation benefit.
Yeah.
So unless you can justify BC is greater than 1,
Mm-hmm.
you'll never be able to justify easily if it's a pure flood control dam.
Mm-hmm.
So that's the idea.
Yeah. Yeah. So
I
I
think the
think that's
same thing with San Roque or Angat. You have other functions. Otherwise, if it's flood control, it won't go through NEDA or something like that.
yes. Okay. So I think the question also from Arvin Sanchez has something to do with the flood control operation or function of Magat Dam. And I think you already mentioned this, that is there a way to actually allow this dam to operate for flood control. I think you mentioned that
Yeah,
already.
you
Yeah.
can do that. In fact, that's being entertained now that maybe in the next 2 weeks, move it down to 185.
Yes.
But the meaning of that, if it doesn't happen, 15,000 hectares out of 85 will not be irrigated.
Mm.
So are you willing to do that? So it really now will depend on very strong confidence in forecasting by the Pagasa. Will
Yes.
happen this way, then let's
Right.
decide on that basis.
Correct. That's true. Okay. So again, you have it's not only the operation, the protocols, but the monitoring as well. It's
Mhm.
important. Now, the you mentioned you actually also presented the JICA study, and they have a lot of recommendations. And it's just there. Not, I don't think many of this or they were not really implemented at this time. But do you support? The question is, do you support this recommendations from JICA?
Well, no, the
Yeah.
JICA studies. I always say this when it comes to water resources planning and management in general, that there is no one big solution because things change. Things change easily. Land use change in about 2 to 3 years. Your river landscape changes right away. So you have to have adaptive planning. Maybe the JICA,
Mm.
some of them are still relevant or current, and in fact, they are still a good option. But unless you build them now, you have to review, reassess again what will be the performance of that flood control function. I mean, flood control infrastructure. So there is no one plan that will work because
Yeah.
definitely for a big basin like that, it's going to be a combination of
Yes.
structural and non-structural measures. And
Correct.
how you
Yeah.
kind of stage and schedule all of this and invest in
Mm.
them. It doesn't, like for example, the dams that they were suggesting 20 years ago, it hasn't been built. Nothing was built.
Okay. Yeah.
So,
This one is, I think, referring to some of the figures that you mentioned about discharges from the Magat reservoir, and there's this figure mentioned by uh, Recarido, Saturay Recarido, that shows that the maximum discharge from Magat is about 7,000, and the one at Bunton
during
Bridge
that
about
time, during
November 12th.
no,
The
it
peak,
was
is
about
that the peak?
6,700, but anyway,
Yeah, yeah.
7,000 more or less.
Uh, and if the peak discharge is roughly 25% of the Bunton Bridge peak discharge, and yet Magat only comprises about less than 20% of the area of the river basin, does this say that the Magat peak discharge may have significantly contributed to the magnitude of flood
No,
downstream?
the idea is this.
Yeah.
It's really the timing of things. Like I mentioned earlier that the estimates of the 100-year peak flow in Magat is 10,000 cubic meters per second in one study. But the maximum peak flow in Cagayan River at the mouth of Cagayan River to Babuyan
Yeah.
Sea is
Yes.
25,000. So you can
Mm-hmm.
think about
Mm-hmm.
1/3 of that. So while we say that, well, it's only 16% as far as the drainage area, but
Yeah.
the contribution being on the high mountain side as opposed to the lower part, maybe difference in timing here and there. So you really have to look at the actual rainfall. As I mentioned earlier, it's so much rainfall variability in that area
Yes.
during the storm. So it
Mm-hmm.
depends if what happened. I'll be interested to know how they came up with the Bunton Bridge. Maybe they have a rating curve because I don't have.
Yes.
The
Probably yes.
27,000 CMS at Bunton Bridge, that means, which is a little bit downstream, that's already like the 100-year return period flood of the Cagayan River way at the
Mm.
Babuyan Strait. I mean, that was that the sea, the outlet.
Yes.
So that's interesting. Of course, that's I don't know if they have a rating curve because there is a water level uh, observation at Bunton Bridge actually.
Okay. Mm.
But that's true.
Oh.
That could be like that.
Mm. Okay, so maybe we can go with Mr. Saturai again and about the figures and if that's the data
I
there that
wonder
needs
if
to be looked
someone
into.
is raising hand, maybe Roy, if or
Yeah.
nobody's raising hand. Maybe we can mix
Where
the
are
two.
the? Oh, let's go to this Laguna Lake first.
Okay.
Okay,
Sir Tito po.
Sir Tito, you want to ask live?
Yeah, I think Tito was raising his hand
Yeah,
way
yeah.
before I started.
Can you hear me, Roy, Glenn?
Yes, yes, sir.
Yes,
Please
yes,
go
yeah.
ahead.
Yeah, I would like to thank Glenn and of course the ICE for sponsoring this event. And again, the name ICE Explains is a very appropriate term. So thank you very much, Tonette, Glenn, Roy, and everybody. I have just two questions, Glenn.
Okay.
Apparently, the problem of sedimentation in
Yes.
even the dam itself and then all the rivers flowing out of the dam is a very big problem. And
Mm-hmm.
again,
Yes.
as we know, Cagayan was the hotbed of logging, etc., until
Mm-hmm.
it stopped. So
Correct. Yeah.
I guess that's the result of all of this irresponsible logging that we had done. So it's good that the government stopped that some 20 years ago. But again, the effect is there. The
Yes.
second point is related with the solutions that you cited. And as you said, there's no one magic solution here, but a combination
Mm-hmm.
of everything, such that a solution, at the end of the day, we might just have to look at what is the best, that has the biggest bang for the buck. So whether it's a tunnel or a across the ocean to Pacific thing, etc., that is something that we might just have to look at. Of course, there are engineering ways of uh, let's say weighing what is the best, but again,
Mm-hmm.
start weighing, then you sub-optimize yung word on, and nothing happens also. But the more important element, Glenn, I like your presentation, but I don't like your conclusion. Citing this, citing the words of that professor, it just tells us that, oy, mga Pilipino, okay na kayo. Huwag ka na kayong
Mm.
gumalaw.
No, of course.
Just live with your life. Nothing happens. Kaya wala nangyayari.
That's
Kaya
why I said just
possible
kind
if
of
you,
okay.
if you please
Mm.
delete that conclusion. But of course, yeah, it's done already. But you should have, I would have said that, we need to do this, number one, number two, number three,
Okay.
rather than citing a professor saying that.
Not, mm.
Nawala yung gana ko eh. But anyway, that's just me. Thank you,
It's
Glenn.
just
Great show, great show.
I'll just tell you about this Greg Bancock.
Uh,
During the Mount Pinatubo
uh,
disaster, he was coming here, and if you look at the some of the writings of our Vice President, VP Cynthia of Academic Affairs, OVPA,
uh,
they had like some because he came here as a sociologist,
I see.
and then he came here, like all this he observed. We have like what we call this. We relegate to the deities, the
Uh,
bahala, the bathala, bale. Pag ito na yung nangyari sa atin, bahala na or si bathala na ang bahala dyan is up to God, etc. So that's the kind of culture of disaster we have.
Mm.
And that
Mm.
particular observation, you're right. Because of that, our DPWAs, for example, major flood control structures are only designed 1:10, 1:20 year return period flood. Because bahala na kayo kung sumobra na doon. And that's, I think, an attitude which is correct. Not,
yeah,
you're right. And to me, in fact, I'm just trying to be intriga. I was nag-iintriga lang ako.
sige.
Because
Okay.
we do not provide a very high level of protection to our people. Para
Yeah.
bang bahala na kayo dyan. Na ganun ang, you can live with it and so on and so on. Which is not, I think, a proper, maybe because of what you call corruption and so on. Some of our flood control structure medyo nakunan ng pera, bumaba because of personal na mga greed, etc. But at the expense of this much more maybe higher level of protection to
More
our people.
critical problem. Yeah.
You
Yes.
know, that's something like
Thank
that.
you, Glenn.
Okay,
Uh,
but that's a good
thank you.
idea. Okay,
Thank you,
Okay.
Tito.
Thank you.
thank you, Tito.
Thank you, Roy.
All right, so we'll move on to the other questions here. From Paulo Pagaduan, is there really well, of course, the one project for flood control is being proposed in Upper Marikina, and another one for water supply. Uh, the question is, has this been included, or what is probably the impact of this?
Yeah. Now the idea was
Proposals.
this. In 2010, 2011, in the master plan of DPWH by JICA, they already have this Marikina Dam as one of them. But later on, there came this because of the water crisis. You know, maybe Professor Roy,
Mm.
that the guy who was holding the water permit for a long time, OV and company,
Yeah.
OV,
Yeah.
was able to somehow transfer the
Yeah.
water, URD and WRB, to the Rason group. So they're building a water supply reservoir, but
Yeah.
it's not the same location as that.
Mm.
But the water supply reservoir is about 140 something meters high. This one is only 81. So in fact,
Mm.
some World Bank people I know, they wanted to talk to me about that because they say maybe it will submerge the Marikina Dam if it's upstream. But I said maybe it's downstream. So there's no, so but definitely who asked that, Paulo
Paulo
Pagaduan, yeah.
Pagaduan. Yeah.
There is no conflict supposedly because one
Mm.
is a water reservoir for conserving water for, saving water for, the other one is a pure flood control.
Yes.
But if they can coordinate, it's good. But uh, I know that the other Marikina Dam, the water supply, I'm familiar with it. So the thing is that they won't just assume some flood control function.
Yes.
Otherwise,
Yeah. So this is
in-
still under discussion.
yeah, yeah, yeah.
Okay. So maybe let's move on to the next. Again, I think it's talking about Magat Dam protocol and the methods for, or how the methods and the
Yeah,
protocols for
based on
modeling and
the,
prediction
yeah,
are established.
yeah, the whole works is really, again, even in my San Roque report before with so many other people, we detailed the decision support system associated with the water, the monitoring, telemetry, etc., and the whole works. Now, of course, that's the state of the art of dam management if you're able to do it. Because
Yeah.
unfortunately, when I did the investigation in San Roque, they were computing using a calculator what is going to be the next move they'll do because this is the elevation now, and 1 hour ago the elevation was this.
Mm.
So based on and so on and so on. But I tell you, unfortunately, the office is closed. In 1986, after I came here, I came back after my PhD. I went back to the US because of everyone was telling you, oh, you go back somewhere else, not in the Philippines. I was doing work in the Dominican Republic through a World Bank project. I was in Colorado State. And in there, we have like the whole works of real-time forecasting. We have the watershed model, interpolate the rainfall as they come in, operate the dam in that surge pool operation elevations already, and then look at the downstream in the Dominican Republic. So I have that report in the office, and there is a chart there that I did,
Mm.
and I wanted to use that actually here. That
Mm.
way back in 1985,
Yeah.
that's already available. But unfortunately, I didn't have a chance. Kasi sarado, wala na akong susi.
Yeah, you can't get
In
in.
HRC. Yeah,
Yes.
So
Uh,
I didn't have time. But
these
if
are
I
already established.
what I'm trying
Yeah,
to say,
this
that's available actually, and it's
already.
just improving the models maybe here and there. But unfortunately,
Mm,
no dam in the Philippines in 2009. I did a study. I mean, I did a investigation sa San Roque. No one has implemented. And then until now, we are still talking about coordination. In
yeah.
the case of Magat,
Mm,
they they coordinate with Pag-asa, but salita-salita lang. You
mm,
really have to
mm.
compute, and you really
Yes.
have to do like a forecasting, and then
Mm,
what is happening upstream, the
mm,
inflow, what is happening downstream. Maybe you should
mm,
not release this because you'll add insult to the injury, something like that.
mm.
So things like
Okay.
that.
Yeah. So let me jump to a question farther down because it's related to this. When you mentioned about coordination, there's a
Yeah.
question. Do you think the Department of Water, having a Department of Water, will help address this kind of issues?
That's again, actually, from 9 to 12 this morning, I have a meeting with this Magat Dam Task Force about the dam operations. Again, I mentioned that because they mentioned about this, maybe ilipat sa NDRRMC
Mm,
yung, the, who will decide the releases.
mm,
Sabi ko, as of now, is the Pag-asa raw ang mag-decide. But on the other hand, there was a discussion, no, it was NIA who decided,
mm,
and so on
mm,
and so on. But I think to me, this is a sort of a coordination of several agencies, like a technical working group when you decide the Angat Dam releases, I mean monthly allocation. It will
mm.
be something like that. But the difference here is that you do it in real time pagkatapos fast pace. Okay, you need a decision support system to compute for you. You could no longer just, teka muna, ah, punta muna, magmerienda muna tayo. You cannot do something like that. It's
Yeah.
real
Yeah.
time, and it should be adaptive feedback,
Yeah.
control, forecast, predictor, corrector, these kinds of things.
Mm,
That's how you will
yeah.
do these things.
Yes, that's true. Well, this is probably more the basic hydrology and from Jason Pinza. This is one of our students actually now in I think in Netherlands. Do you think
Mhm.
the initial moisture content, you know, uh, before the rainfall actually contributed to the flooding?
I think that happens, but that's always in hydrology.
Yeah,
The first, the first 30 centimeters of your soil defines your ponding time.
yeah, yeah,
Once it gets ponded, maybe in a matter of a few minutes, then everything
mm,
just goes down. I mean,
yeah,
there's no such thing as a infinitely. Uh, it will not pond for 1 hour or 2 hours. In a matter of a few
yeah,
minutes, it will pond. So the upper 30 centimeters, once it's
mm,
ponded, you go at the rate of hydraulic conductivity lang. So
yes,
that's,
yes,
I think, so in other words, the initial soil moisture condition of the soil, when you talk about ponding, maybe if you have a flow of, I mean, you have a rainfall of 1 mm, 2 mm per hour. But if you're
mm,
talking 20 in a matter of a few minutes, that's already ponded. It already
mm,
attained saturation at
mm,
that layer.
mm, mm. Yeah. Let me lump up three questions here. I think they're asking about other mitigating measures from Lucky De La Rosa asking about, okay, now that there's this uh, number of land conversions
Mm-hmm.
in, let's say, Rizal and the Marikina area, and some mining operations.
Mm.
So that is the could that be of course some of the factors that are contributing, and of course to add to that, one of the things that are being already brought forward as a way forward is the one mentioned by Marnie Ortega, that is the
Greening.
greening program, especially by DNR. So what do you think? Do you think these are way
Good
forward? These are
idea.
good suggestions. And how would they actually, influence or affect the results?
Yeah. Let me just tell you a story instead. before I joined University of the Philippines in 1996, I was doing work in the US, right? I was in Berkeley.
Mm,
And then I was doing work with the Santa Clara Valley Water District,
mm,
which covers Silicon Valley, the Silicon Valley of the USA, where you have all these big companies, dot-coms before and so on. So every 3 years they review their flood control plans because
mm,
they cover the water district. By the way, in that case, they cover the conservation watersheds, flood control, groundwater extraction, water supply from surface. They own surface reservoir, hydropower, etc. So that's
yeah.
the water. This is like our Philippines with the Department of Water
Yes. Okay.
or a
So you.
National Water Council before, Water Resource Council, not the
Yes.
NWRB now.
Yes. Yes.
Every time there is a development, like Cisco company, that's a big networking
Mm,
company, you are talking about Santa Clara Valley water, Santa Clara Valley, that's the from Redwood all the way to San Jose, all the way to South Park, Gilroy, is about
mm,
400 square kilometers. Small area, but it's a very rich area. Every time there is one company making just a campus, they call it, like a big factory and so on, you have to submit to the water district what is the flood control impact of that, traffic impact of that,
mm,
noise impact of that, etc., environmental impact, so to speak. And this is a serious job. Like I am now the consultant of the Santa Clara Valley Water District. I do the simulation. What's the effect? Now, a small development like that maybe will occupy maybe 4,000 square meters.
mm,
And this is the entire, 400 square kilometers. They spend maybe a few 100,000 uh, dollars for that kind of analysis and so on. So that's the kind of job supposedly we should do. If you have a mining company doing this, you go to ECC. But what kind of ECC you do to be able to, or what kind of study you do to get your ECC? Maybe it's just a checklist. Yes, the effect is high or low and so on. You really have to run models like that. And that's the kind of thing I was doing. If you think about a mall, you put up a mall in what's that, University Avenue, UP, let's say.
mm,
What's the impact on traffic? Do you just say a checklist, yes, high or low, and so on? Maybe you do a simulation. What will be the coming in and going out? What will be the effect on the foot traffic? What will be the effect on the vehicular traffic, etc.? So this should be the kind of thing that we should do, but can we afford that? Can we do that? Or we just do a shortcut?
mm,
So in any case, the case like that, national greening and so on, you have only 100 million pesos, let's say. You have a Marikina River basin of 530 square kilometers. How do you prioritize where to do the reforestation if you have only that much? Because that's not a lot of money. In San Roque, they did that for about 30 or 40 million pesos. You're talking about 580 square kilometers of a river. How do you prioritize that?
mm. Yeah. So that's a matter of implementation as well. All
May I
right.
ask
So
another question, Roy?
yes, go ahead. Okay,
Ah,
go ahead, Tito. Go
Actually,
ahead.
thank you very much, Glenn. All your explanations are very profound and the results of the in-depth studies. What I would suggest is, meron kang sinuggest the three-tiered approach.
3-tier approach, yeah.
Yeah, maybe what we can do is that that approach is something that we can, or you can do. Like, for instance, if there's three typhoons coming in
Mm-hmm.
the next 2 weeks, and of course we don't know yet where it will go, but maybe you can
Yeah.
already start developing a formula that if this hits Cagayan Valley within 1 week of each other, this is what's going to happen. So step one, tier one, we do this already, tier two, etc.
Yeah.
Nobody will probably listen to you, but at least that's something that from a simulation standpoint,
Mm.
it's worth looking at. And I'm sure there will be one or two guys who will decide, sasabihin, "Hoy, tingnan natin yung study ni ni Prof. Tabios. Maghanda kayo." Okay? Because again, like yung ninuno namin sa mga Isabela, sabi na, alam mo nung kami, basta magkasunod na typhoon na isang within 1 week problema. That was a basic rule of thumb.
Yeah. Yeah.
And again, I suppose they were aware of the drainage problem, etc., etc. And like what type happened with Ulysses and Rolly, within 3 days it happened. So you could
Yes.
see
Yeah.
that at the end of the day, yung observation ng mga lolo natin tama eh. But you're right, meron tayong three-tiered solution that if this happens,
No,
like in
it's a
Camarines,
three-tier, yeah.
yeah,
It
if
looks
it
at the
happens,
three-tier.
yeah.
It
So,
looks at the long-term na mga objectives, tapos yung medium-term, at saka yung short-term, bale.
yun nga.
Because flood control, you're talking about hours. When you talk about irrigation, maybe you're talking about weeks or months, bale, yung preparation mo. Pero how you reconcile all these long-term and short-term objectives, that's the idea behind that one.
Actually,
And
I
then
was just may values.
everything is uncertain. If you
Yeah.
look at 2 months from now, very uncertain yan as opposed to the next 72 hours. But if you're talking about big amounts of flow, the fluctuations, the variation of big amounts of flow will also create a lot of uncertainty as opposed to
Yeah.
average flows in the next 2 to 3 months. So this is a complex interplay of dynamics of things and uncertainty.
No, actually, I was using the word three-tier really as a way of forecasting incoming
Okay.
problems.
But that's
Maybe
what I'm talking
we
about.
use,
Yung,
yeah, na 2 weeks from now, this typhoon is coming up. 1 week from now, then we know that, in
yes.
this area, let's prepare. So it's really more of really a disaster preparation.
Actually, that's
Easy
where
to
I
do.
was coming from also.
Yeah,
Kasi meron nga, yung long-term outlook mo depends on your long-term or long-time interval na mga forecast
yeah,
of
yeah.
what to expect. But maybe within that long-term forecast, let's say on a weekly basis, you disaggregate that on a daily and you disaggregate on an hourly. Pero yung risk ng near future na hourly, it should still be harmonized with the weekly na mga forecast mo.
Yep, yep.
And that's what
Thank
I
you.
was saying. And that's been done actually, yung disaggregation modeling.
I see.
If you look at my resume, I do a lot of stochastic hydrology, and that's where the stochastic hydrology comes in.
No,
You deal with
what
uncertainties, bale.
what I'm saying is that, somebody was talking about who will decide what to do. And ako na, I will suggest na Professor Tabios, based on his simulation,
Yes.
this might happen. So,
Yeah, the reason why, Tito, you have to do simulation, I always say that, it's like going to war.
yeah,
Meron
yeah,
kang kalaban na hindi mo nakikita ano yung gagawin nila, ano yung
correct. Yeah, yeah.
strategy na, and you have to do it. It's like a chess.
You
Pero
have to do
ito,
hand run.
blind ka. So
Yeah.
you have to be prepared. You have to be able to anticipate kung itong ginawa nila, ito yung gagawin mo.
Yeah.
Kung itong ginawa nila, yun ang gagawin mo.
Yeah.
And these kinds of things, you cannot do that by doing it without any study, bali na
Yeah,
you simulate those possible scenarios.
correct.
Once you're very good at it already, alam mo na, ito yung ugali nitong tao nito, alam ko na paano mag-deal niyan. Ito, nagbago yung ugali, uminom siya, nagbago yung ugali niya. Alam ko rin paano i-deal yan because I already kind of simulated those kinds of possible scenarios and possible actions I will make.
Okay.
And
Thank you, Glenn.
response.
Thank you.
Okay, let's continue. Let's read through the chat box. I think there's one from Kelvin. It's a comment from Kelvin Mabao. Mangahan floodway capacity is only 2,000 CMS.
Design at 2,900 pero maybe now it's about 2,200 because of that
Yeah, constriction
mga
and all other.
encroachment or mga friction,
Yeah.
friction.
Correct. From Jesse Filisardo of course, DPWH.
Yeah, DPWH.
A proposed tunnel may be costly. The one, the alternative considering distance, elevation between Marikina River and Pacific Ocean, and of
Mhm.
course the terrain that will be traversed. So this is a probably is comment on the proposed alternative. But of course,
The
this that's
cost there is just is cheaper than the
yes,
Paranaque diking of Laguna, which is 140 billion.
correct.
The other thing is that we have already experienced. We built this uh, Umiray Anga Tunnel, 2 billion in 2002. It's a 9-meter diameter tunnel, 13 kilometers. Now we're going to build a subway from Tandansora in Mindanao all the way to Naiya. I don't know what's the cost. Maybe we can borrow yung TBM nila and then bring it to Marikina
Mm,
after they finish that.
mm, mm.
But anyway, that's
Yes.
I think the
Mm,
cost of 50 billion, that's the same cost as the Paranaque Spillway, where you have
mm,
to pump and so on. That's the cost. And then the
yeah,
added cost, umabot ng 140, is your
yeah.
But the bigger thing there is really you no longer have to store water in Laguna Lake where it has a residence time and then
Mm,
flush it out. Dito continuous. Walang
mm,
residence time. It will just go directly. So kung sustain yung mga storms na to, it will keep on just flowing out. It's like a big, uh, essentially a tunnel. I mean, it's a diversion tunnel instead of a
mm,
channel
yeah,
that moves water on the other side. It's about
correct.
40 kilometers, the longest
Mm,
one. It can be less than that.
okay, thank you. So this is okay. Maybe on master planning, I think Florimond Esteban uh, is asking, do we have a real 25-year master plan? I don't know what's a real from not real. To mitigate the yearly floods in the Philippines, or do we just maintain and repair as necessary? I think you have mentioned maybe more specifically what are the master plans that have already been done in the specifically in the areas that Marikina and Cagayan.
Yeah. Actually, the point with master plan, I always keep on honing on that na these days, hindi na pwede yung mga master plan, bale.
Yeah.
We have to have a continuous planning, adaptive planning, because every 5 years nagbabago. And all our priorities are changing also. So if we prioritize our investments in this and that, maybe we have to look at piecewise engineering. That's always how I say it. With in sustainability science, kasi we have to recognize the evolutionary new nature. You
Mm,
have climate change, which is a little bit longer term, but
yeah.
the land use change, the political changes, even yung mga economic changes, because maglagay ka ng mall dito, meron ka ng progress in this and that, even the technology. You have to do piecewise engineering na lang. So the
Mm,
ability to improvise, para bang sa Bisaya, I forgot the name, but ayum sa Bisaya. Meron kang you did this one, but
mm,
you have to anticipate na pwedeng dagdagan mo dapat yon. Dagdagan mo ng ganon. Hindi pwedeng, I will now build the whole thing because that will be good for the next 50 years. And that's
mm,
the essence of project sequencing and staging, bale. We do that
mm.
in water resource systems engineering. We don't want
Yes.
to pour our resources now just because we want to satisfy the demand 25 years from now. Parang
Yes.
ganon.
Yeah.
We try to build it by stages, bale.
Yes. Okay. So let's just go through some of the questions. We still have like 7 minutes left. So,
Okay?
what would be the
Akala
best
ko
flood
7 hours
mitigation?
left.
Oh yeah, kaya pa ni
Okay.
Doc. What would be the best from Jenny Calot? What would be the best flood mitigation measure or measures? What are the best? Okay, that you can suggest to solve the flooding around Marikina and Rizal
And Rizal.
areas.
Again, as I was saying
Yeah,
earlier,
yeah,
it's
yeah.
really a combination of
Mm,
things. You cannot have
mm,
like one solution or one catch-all
mm,
solution, bale.
yeah.
Yeah, like the one I suggest yung tunnel, it will carry
Mm,
maybe 30%, 40%.
yeah.
Pag doon nanggaling yung tubig. But if you have, like in Camiguin in 1996 pa yun, there was a rain that just stayed raining.
Mm.
So, nagkaroon sila ng debris flow, etc. Whatever flood control you have, walang magawa, napuno na lahat. Yung
Yeah.
ganun bale. But in any case,
Correct.
like, you have to have a combination. In fact,
Mm.
I think about the Metro Manila, yung old Manila in particular, like
Mm.
you're talking about España and so on,
Mm.
you could have built the buildings na sa ilalim open.
Yes.
Pero if
Yes.
you went there in 1970, there was a flood storage at the bottom. Sa España, hindi pa nawala yun kasi because of limitation. But the other thing is that why they allowed yung public works, they have been building yung road higher and higher, yung mga bahay na iwan.
Yes. Exactly.
I
Yeah.
used to go there a lot because my brother went
Yeah.
to UST,
Yes.
I go there, pag pupunta ka sa restaurant,
Mm-mm.
papanik ka na mataas.
The roads
Pero
are higher than, yeah.
mang mababas. So
Exactly. Yeah.
the flood disaster will happen now because
In
mas
the living
mababa yung
room,
mga
in the living
stay
and
in the
dining
living
room.
room. That kind
Yes.
of thing.
That becomes the catchment. Yeah.
Yeah, that because yung bahay mo
Yes.
mismo.
Yes. Exactly. There's a question here, but it's not really related to the flooding. But I think he just wants your opinion on this. Are you in favor of building Kaliwa Dam?
Actually, I
Maybe
did a
just a
study
comment.
at
I know.
Kaliwata.
I know. Just to probably give an answer
I
to
think
Harry Garcia.
there is no, I don't have any issue with it. In fact, I was one of the proponents to
Mm.
being on the hydrologic point of view, the climate on the west, on the eastern side of the Sierra Madre, it's type 3, 4, something. All year round, may ulan ka.
Mm.
I think if you build Angat on this side, in 1968, if you build in the Kaliwa, it would have a better location to build a dam.
Exactly. Yes.
So I don't know exactly why,
Yeah. Yeah, maybe it's other issues that are coming up.
Yeah,
But
there are other
yeah,
issues, but I think
yeah. From the perspective of a resource, I think that's a good place to tap. Um, okay, there's one from Invictus Fiesta. What are the mitigating measures to the areas where there is still water flooding up to now? Up to now in Cagayan, just talking about those that are low-lying, probably still that are still inundated up to this point, if that is correct. No?
yeah, I think those are things I was saying. I don't know, because I don't know where they are,
Yes.
but they require some point specific na mga solutions. Pero on a bigger, on a basin scale na mga solutions, meron bale. So if it's not going to be fixed by structural, you have a non-structural measure. Just like, for example, in Agusan River Basin, they have accepted that the Agusan Marsh is an area where it gets flooded every year. And from 3,000 hectares, it can get flooded all the way 20,000 hectares. That's about 200 square kilometers, divided by 100, right? From about 50 to 200, so that's like half of Laguna Lake, a little bit more than half of Laguna Lake. Yung lake is 300. But people learn to live already there. All the houses are on stilt, or some of the houses on stilt, pero may mga bangka na sila. And during the flooded ponds, they will just use the boats as a transport. I've been there way back then, 2008 and so on. But in any case, that's life to them. And if you go to Danang, in the higher part, there is a city on Hoinan that's in Tubon River. Tubon River goes as high as 5 meters, 7 meters high. Lahat yung mga bahay nila, maybe, I don't know if you've been there, Roy, sa ilalim is a sala. Sa itaas lang yung living area.
Yeah.
Puro sala lang. Have you seen
Adapted
those?
na sila. May mga naka-adapt na
Na ganon.
elevate.
So maybe some areas that you have this one, that's how you would do it.
Adaptive
Adaptive
design
na
of
ba?
yes, exactly. Live with it. Yeah. Prisco
Okay.
okay, this is from Pagasa, right? There's an observation that the dikes constructed along Marikina River was constructed has constricted the flow and worsened the flooding during Typhoon Ulysses.
It could be, that's one of the things in Marikina River. Either the dike is not quite uh, proper, but on the other hand, the big issue there, I would say, is also sedimentation. No? And I always give that as an example. In 1990s, late 1990s, if you go to across from UP, you go down
Mm,
MWSS, you cross Tumana Bridge,
mm,
that is an overflow bridge. There's a culvert at the bottom. It's concrete. You go through it. I think in mga 2000 meron ng naano doon, natangay because dumiretso pa rin. Tapos the
mm,
whole car went down. But after 2005, 2000, especially after Ondoy, nag-accumulate doon sediments mga 2 meters high. Nawala na
mm,
yon. Hindi mo na
mm,
nakikita yung Tumana Bridge na yun na lower, but you have the bridge on top, of course.
mm,
So while maybe some of the constriction happened, like for example, if I remember, because I did work on Circulo Verde Law
yeah,
to
yeah.
realign that
Mm,
part actually pag-ikot doon, before it goes into Lower Marikina River, during Ondoy, ang dahil na-accumulate doon, just right across, if you're in FCOS na office bali ng MMDA,
mm,
you
mm.
can see below that part, so much sediment just got, accumulated. So,
That's an accretion point.
ang accretion, yung paikot na
Mm.
ganon, pag
Yeah,
ikot
yeah,
niya
yeah.
doon,
The bend.
magpaano,
Yeah. Mm,
nag-deposit. So they have a
deposit.
flood wall there. In fact, Sir
Mm,
built a flood wall
mm.
higher. But
Yes,
sooner or
yes.
later, whatever is the alignment that they made, because of the
Mm,
accumulation, akala mo,
mm,
naging constriction na yan. But actually, maybe it's the bottom
yeah.
bed that made
Mm,
the river shallow. So
yes,
naging parang constriction tingnan.
correct. Okay, so that's possible in some areas. No?
In some areas. Yeah.
Yeah, I think there are two questions related to the return periods. No, so do you think the return periods from Jason Gabriel Pinza and also from Chris Marponsala? These are both our students in water resources. No? Do you think the return periods use a guide as guides for designing our control, flood control facilities are still applicable, or do you need to now, probably come up with a new design criteria?
Yeah, that's a good point actually, because that's what I was mentioning earlier. Now yung peak flow is based on yung return period na yan, no?
Yes.
Rather than yung duration rin.
Mm-mm.
So if you really design, you have to look at especially in tropical countries like the Philippines, yung humid tropic na climate, Well, we can have like very sharp thunderstorms, and then even yung mga typhoons. But if you have monsoons that can last several days, that's what you call the Joseph effect. Yung
Mm.
Noah effect kasi, Noah flood, mabilis.
Mm-mm.
Babagsak ka dyan. Pero yung Joseph effect, prolong so many days ng madaming ulan. So iba ng klaseng return period yun. You're looking at
Mm.
durations
Yeah.
also.
Yes.
So
Yes.
definitely, that's a very good question, but on point. And that's what I was emphasizing
Mm.
earlier. Yung difference ng Undoy, mabilis, mas mataas.
Mm.
Kaya lang, yung Ulysses, mas mababa yung rainfall, kaya lang mas mahaba. So the effect
Yes.
is the same. The flooding result is the same.
Yes. Well, I think we are way past the time that we have
Nandito si
allocated.
Frisco Nilo,
Yes, he
I
asked
haven't
one of
seen
the
him for
questions.
a long time.
I know. I read one. The question I asked earlier was from him.
Oh,
So
okay. Even
maybe
si
what we
Rene,
will.
a friend of mine from NIA is there.
Yes.
Rene
What we
Ugay.
will do is just give you these questions, and you can probably answer them on your own by email, because
In
there
the
are a
next
lot
few
more
months.
in the next few months. There are a lot more here. Most of them
Oh,
are
okay.
similar.
Actually, there was,
And
just to acknowledge before a few days ago, a friend of mine also, Simon Ramirez, of Bradney Leong's son, my
Mm.
cousin.
Mm.
He had
Mm.
some questions asked
Okay.
actually, and I think perhaps I answered him in my presentation, in my questions. Yeah,
Okay. Mm.
but uh, Simon, ate, yeah, Simon, you can ask me Mon anytime. Maybe
Mm.
he must be like up there.
Okay. Okay.
So you can always email me Mon. He
Okay.
was the one who put my Marikina lecture 2010, 2009,
Mm.
just 6 days after in the Arkibong Bayan
Mm.
website or wherever that
Yeah.
YouTube
Yeah.
thing.
Okay. So that's the. I think that's the way we can now deal with all of this. There's still some more, but I said we don't
Okay.
have enough time. So you will be given all these lists of questions for you to answer them on your own
Okay. I
time.
think if you're recording it, it will be in that
Yes.
in the
Yeah.
recorded. Yeah.
And last question, I will throw it to you, and I will try to see how you would react to this one.
Mhm.
From Allen Jake Discaya. Dr. Tabios, if given the chance, are you willing to be assigned as the secretary of the proposed Department of Water?
Of course, I was one of the proponents there way back then, and I mean, I know how the whole framework, the mechanics of running that kind of as I envisioned it way back then, because I wrote a good, I mean, the policy paper and then the implementation. That is something to consider, but hindi man tayo retire niyan. Of course, si Secretary de la Peña nag-retire after they became Secretary of the UST.
Yes.
But
Okay.
that depends in who is the president anyway.
Mm-hmm. Okay, so I think I will end the Q&A
Okay.
with that one, and I'll bring you back, give you back the floor to Amy. Thank you, Dr. Tabios.
Thank you, Roy. Thank you very much, Dr.
Thank
Roy.
you. Thank you, Sir Roy. So we still have lots of questions, but we do not have time. So we apologize that we cannot accommodate all of the questions. And we would also like to thank Dr. Tabios
Thank you.
for sharing his valuable knowledge, no, in the 2020 Marikina and Cagayan flooding. So Sir Tabios just launched his new book. So maybe Doc Tabios can share with us his new book, sir. Can
You
you tell
mean
us
for
about
free?
your new book?
Binigyan ko na si Amy.
Or maybe you
I
can also share with the others about
I
your.
showed you have a copy there behind you. You can probably show them.
Yeah, oh, here.
Yeah, I can see it. Yeah,
Just to advertise, the color of this is same as your
yeah,
ICExplains.
yeah.
I see it and then I explain. But
Okay.
this is, of course, a book about the applications to Philippine water resource systems. And if you look at it, it covers actually from surface, groundwater studies, flood control, dam break, reservoir operations, some things on climate change, and so on and so on. So I think it's available for a few euros more.
Yeah.
But otherwise, if you're a friend of mine, maybe you can email me. I'll see what I can do. No, I'm not saying if I'm a friend of yours, but rather, you know. But
Okay.
that's that book.
Okay, so thank you, sir. We would also
Thank
like
you.
to thank Dr. Soriano for moderating the session. And then Sir Tito Aliga from the UP Earthy. Thank you, sir. And we would also like to thank our faculty, students, and of course, the participants who stayed with us until the end. And we have around 450 at some point here in Zoom. We have 450 participants and around 400 views in Facebook, 400 views and counting in Facebook. So we would like to thank all of our participants for staying with us, for sharing your valuable time. And we hope we have given you your expectations no, on the 2020 Marikina and Cagayan flooding webinar. So this is the first ICE Explain series. We hope that we could give another series no, in the future.
Yes.
So stay tuned to our next ICE Explain series. Thank you very much, everyone. Good evening, and I hope you had a good day. So good evening and happy weekend. Thank you very
Thank you
much.
very
Thank
much,
you very much,
Amy.
Amy. Thank you,
Thank you,
Tito.
Amy.
Thank you,
Thank
Thank
Roy.
you
you.
very much,
Thank you.
Amy, ICE, Glenn,
Yeah.
And
Roy, for hosting this great event. And we look forward to be invited to IC Explains Episode 2. Thank you, and let's all have a great week. And happy Thanksgiving as well.
Oh, yeah.
Okay.
Thank you very
Um,
That's
much.
right.
we would also like to thank our partner, the Philippine
Yeah.
Institute of Civil Engineers.
Oh, I see.
Yes, that's right.
Okay.